Don't you hate it when this happens? You're perfectly happy with what you have, then you find something that's so much better that everything else turns to garbage. This luxurious trackpad on the XPS 15, garbage. The pinnacle of touchpad design on this MacBook here, limp garbage. And that's no exaggeration. The folks over at Sensel can honestly call this touchpad a completely new way to interact with your laptop or phone, and I am super excited to be the first one to properly explain it. Just like I'm going to explain why you should check out our sponsor, CableMod. CableMod allows you to personalize the look of your PC with custom colored sleeved cables. Try out their configurator at the link below and build your cables exactly how you want them. The ThinkPad X1 Titanium is equipped with the first proper trackpad using Sensel's Force Touch technology, which is a completely new way for touchpads to work and allows you to do some really cool things, like operate the touchpad flawlessly with a big winter glove on. But before we can really appreciate how revolutionary this tech is, we need a short history lesson. Resistive touchpads were most popular in early laptops, and they operate by having two conductive layers separated by some insulating pads. When your finger touches the touchpad, it deforms and completes the circuit between the top and bottom layers. The resistance in the circuit is then measured by 4 sensors on the edge of the trackpad to figure out where your finger is. And while this method is pretty good if your hand is in a glove, that's about all it's good for. Resistive trackpads make the screen look cloudy, they suffer from poor accuracy, and they generally only have support for a single touch point. So perfect for a bus ticket dispenser and not much else today. Now, most modern touchpads or touchscreens are capacitive, and they work on the principle that your body is a bit electrically conductive. So basically, below the surface of it then is a grid of electrodes that are positively and negatively charged. And as your finger comes into contact with the surface, the charge distribution between these electrodes changes. This is picked up by a circuit in your phone or your touchpad and turned into the position of your finger. For more detail on this, check out this video by The Physics Girl. She does a great job of explaining the whole chain to go from finger to poop emoji. What's different about Sensel's touchpad is that instead of using the electricity in your finger, it looks at the force you're applying. And this is achieved using what's called a force sensing resistor, or FSR. FSRs work by having a conductive layer, normally printed silver, with a whole bunch of tightly packed traces. And then above this is a polymer that consists of a bunch of super small electrically conductive particles suspended in a non-conductive material. So then as force is applied to the polymer, compressing it, the electrically conductive particles get closer together and create a bunch of different electrical pathways, which is essentially a bunch of little short circuits across the silver conductor. This changes the resistance measured across the conductive film, which can be turned into a measured amount of force. Where it gets really complicated, sorry, this wasn't complicated yet?
Not at all.
Where it gets really complicated is that none of those tiny conductive particles ever actually touch each other. So then, how do they short? I'm so glad you asked. As a force is applied to the FSR, the chances of quantum tunneling between these particles increases, which increases the chances of electrons hippity-hopping between the conductive particles, decreasing the resistance of the FSR.
So quick note about that. We talked to the guys over at Sensel after the shoot, and they said that experts in the field don't agree on the exact mechanism of how FSRs work, only committing to say, I prefer to think of it simply as conductivity changing as contact area between the FSR layer and the electrodes changes on a microscopic scale. So don't trust everything you read on Wikipedia, kids. They're paid off by big quantum.
Now, those of you in the science and maker crowds will probably know that FSRs are nothing new, but to be used in a touchpad, they need to be much smaller and way more accurate than traditional FSRs. And Sensel was able to achieve this by making each FSR just 1 millimeter. So that means there are a lot of freaking force sensors in even a small trackpad like this one, nearly 6,000 by our rough count. What this translates to in the real world then is exceptional tracking accuracy. I mean, think about it this way. What gives you a more detailed picture? Lots of megapixels or just a few megapixels? Well, okay, it's a bit more complicated than that, but the basic idea applies because on traditional capacitive touchpads, each electrode is a whopping 4 millimeters apart. And as you're moving, sliding your finger around from one electrode to the next, the electrical signal that's outputted is super non-linear, greatly reducing the trackpad's accuracy. So to combat this, a whole bunch of complicated tuning has to be applied to the trackpad to make your fingers' movements accurate. That's why Apple's trackpads are so good, because they spend so much time on this step. But with Sensel's FSRs, the raw output from the trackpad is already really good. Now, you might be thinking, oh yeah, Apple, don't they already have this whole pushing down on trackpads thing figured out? Well, no. 3D Touch, RIP, used capacitive sensors that detected the distance between the front glass and the backlight in your phone. And as for Force Touch, well there, Apple's just using a regular capacitive touchpad. Then they're simulating the feel of a click using 2 solenoids placed below its surface. So you press down and they vibrate a bit to give you some delightful haptic feedback. And, this is cool, Sensel has an ingenious answer to that as well. What they realized was that they're already printing a PCB. So on a layer below all the FSRs, they could just print a big old coil. And with the help of some magnets below the touchpad, the whole thing turns into a speaker. For more information on how exactly that works, you can check out our video on voice coils. But there are 2 main advantages of doing haptics this way. First, it's much cheaper than adding solenoids after the fact. And second, the whole thing is super small. The Z height of Sensel's trackpad is only 3 millimeters. So by using both the force data and the voice coil, the level of tuning that's possible on a touchpad like this is staggering. We're killing 2 birds with 1 stone here, getting in a webcam test for the ThinkPad X1 Titanium. I'm in the Sensel configurator, and there's a whole bunch of stuff that we can change here. So why don't we try the crisp click preset? Oh, it almost feels like a mouse switch. It has a sound to it, which I guess makes sense, it is a speaker. That's crazy. It actually feels like it's moving further down because it's like a click, click, instead of like a tick. I bet you can even hear the difference in the sound. Hold on, I'm gonna try and get this up to the microphone here. Okay, check this out. David, can you hear this? Here's deep click. It feels that different. And then, if you wanna get really crazy time, you can actually tune it yourself. I wanna change it to 500 grams of force. Oh yeah, 500 gram deep click. Oh man, that is not necessary. Okay, go down 28 grams of force. Oh, it almost feels like getting like zapped with Electro Boom or whatever. Like you just touch it and it's like, oh hey, hi, how you doing? Ah! That's the kind of technology advancement that just puts a smile on your face. But there is one problem with using a purely FSR trackpad. It can be a little on the expensive side. So you will see some PCs adopt this tech, like the ThinkPad X1 Titanium. But Sensel knows that most of these are gonna end up in industrial and medical devices where accurate tracking through gloves is a requirement. The good news though, is that this trackpad here actually uses a combination of FSR and traditional capacitive touch, and it still feels great. Now, I wasn't able to get exact details on how it works because the patent is still going through, but Sensel was able to say that they applied the same principles that allowed them to shrink down their FSRs to their capacitive touchpad electrodes, and they got them down to 1 millimeter as well to improve accuracy. Then they added some FSR goodness around the outsides. So what we've got here is a 2-layer PCB where the top one is a conventional capacitive touchpad, and then the second one is a ring of FSRs with a voice coil in the center. This kind of integration is only possible when a single supplier is creating every part of the stack, since, as you can probably imagine, turning on a voice coil isn't great for the accuracy of capacitive touch if you're not able to compensate for it. Which brings us to the big question then. Should you buy the ThinkPad X1 Titanium today? Well, it's complicated. The tracking, absolutely exceptional. see you later, synaptics. Is that what they're called? But sometimes in life, size does matter, and this is one of those situations. So you get all the benefits of an FSR-based touchpad. It works great with a glove, or even if it's a bit wet. But Lenovo, possibly due to the prohibitive cost, only gave us 3.5 inches. It also uses a third-party haptic solution, so the click detail isn't the same as on our standalone engineering sample trackpad here. But we're still super bullish on this technology. Sensel said they're already working with a bunch of OEMs to bring their trackpads into more laptops, and it is not an overstatement to say that this will change how we interact with our computers. For instance, with this technology, it would be possible to make a touchpad that goes all the way across the bottom of a laptop, since palm rejection is way easier using force data. Or you could make laptops that integrate some of the cool stuff that we checked out in our recent Sensel Morph video, like modular slap-on magnetic interfaces or unlimited macro buttons. The added functionality of the voice coil could also add another dimension, like you could have different feels for different buttons, or if you're turning them on or off, or a different click if you have an invalid entry on a form, or you could have it do a celebratory buzz if you buy something on lttstore.com, like this great looking stealth hoodie. So, bottom line, laptop makers, if you haven't done it yet, get in touch with these guys. Get it? Because every other trackpad feels terrible now that I've used it. Just like every other sponsor segue feels terrible once you've heard mine. Get the best prices and best selection on computer hardware and everything else technology at any one of Micro Center's 25 locations across the United States. Check out the Micro Center Custom PC Builder if you want to spec out the best PC for your budget. It'll help you ensure all your parts are compatible and available at the nearest Micro Center location, and you just add it to your cart and arrange same-day in-store pickup. For a fee, you can also check the box marked Same-Day Pro Assembly, and Micro Center's expert technicians will assemble the PC for you. If you want help deciding what parts to put in your new custom gaming PC, just join the new online Micro Center community. It's a great place to discuss tech with other enthusiasts. Also, as a final, but wait, there's more, see the link in the description for a free pair of wireless Bluetooth headphones. Valid in store only, no purchase necessary. If you guys enjoyed this video and you're looking for another total nerd out video, then check out How Motherboards Work Turbo Nerd Edition. I guarantee you will learn something. Unless you're like Bill Zoid or Steve from Gamers Nexus or something.